Hey guys, welcome to lesson 112. Yesterday we talked a lot about functions and inputs and outputs and just mainly focused on the equations themselves. And today we're going to go ahead and focus on the graphing aspect of things. So we're going to graph some functions and also point out some key points about those functions. So the first one we're going to work with is square root of x plus 2 minus 1, and note that that minus 1 is outside of the square root. So what we're going to do is actually use our calculator, and you guys are going to need to have this calculator downloaded onto your Chromebooks. So you're going to click this y equals button, and this y equals is the same thing as this f of x equals. So here you're just going to type in your function. So you'll click second and this button, see that blue square root there? And you'll click x plus 2 and click the right arrow to get out of the square root, and then put put the minus 1, hit graph. Okay, and you'll see we got a nice little picture there, and we actually want to get a table of points first so that we can make a pretty accurate graph. So if you look at the graph button, there's a blue word right above it saying table. So we'll press our blue button and then hit graph, and it'll give us a table. So we want to make sure that we can get things on the left and right sides of our graph. So if we go ahead and scroll up, we'll notice that we can go up to -2 on the x-axis. Everything above that is error. So we can just go ahead and start our point values at -2 and -1, -1, 0, 0, 0.41, 2 decimal places is fine, 1.73, and then you want to try to get some good whole number values too, just so that we'll have an easier time graphing. So some decimals are fine, but it'll be nice to have some whole numbers here. So at 2 we have 1, and if we go down a little more, you'll notice that we have 7, 2. That's plenty of points for us to draw a decent picture here. So -2, 1 is a point that's going to go 2 to the left and then down 1. So we're going to start here. And then -1, 0. So we always start at 0, left 1, 0, up and down. So we'll stop right there. 0.41, that's going to fall somewhere around here, a little bit under 0.5, right? 1, and then 0.73, so right 1, up 0.73-ish. Just estimate with these decimals. 2, 1, so right 2, up 1, and then 7, 2. That'll be right over there. And I'm going to try to draw a good graph, but sometimes my pictures are a little questionable with this pen thing I'm using. Alright, I've had better graphs, but it's alright. And you'll see that it looks a lot like this picture right over here. So we're going to go ahead and scroll down here and talk about some key points on this graph. So x-intercepts is where I hit the x-axis, right? And this horizontal line is the x-axis right here, as I've indicated. And so this point right over here is the one that touches the x-axis, and that's actually at -1, 0. So we can say that -1, 0 is our x-intercept. And the y-intercept, kind of similar to the x-intercept, but this time it's where the graph hits the vertical up and down axis. And here I've written that it's the y-axis. That's going to be this point. And that's actually this point right over here, the 0, 0.41. And something important to notice is that both of these have a 0 in them. So a way to recognize x-intercepts is to see which points have a y value of 0. Okay, because this is the y value, it's always x, y. And then y-intercepts is when x equals 0. Okay, Now, a minimum is the smallest point on the graph. Okay, the lowest point, I should say. So here, our minimum, the lowest we'll ever get is going to be this point right over here, because we can't get any lower. It really just stops. And that point is -2, -1. Let's find another color here. Okay, and then for maximum, notice how I've drawn an arrow here, right? And in the calculator, it just like goes and hits the screen. And what this means is that it's actually just going to go on forever and ever, right, until the world ends. That's why I've drawn an arrow, and that kind of indicates that it's going to get higher and higher and higher till the end of time, right? So we can go ahead and write that there is no maximum. Okay, there isn't a maximum point because it's just going to get higher forever. And axis of symmetry, we're actually going to talk about more in the next one. There isn't one for this graph, and you will see why very shortly. Okay, and that is all for this function. We're going to go ahead and do another one. All right, so this function is going to be, in parentheses, we got x minus 3 times x minus 7. Okay, and just like last time, we're going to go to the y equals, clear that first one out, and then type in our new function. Hit graph. All right, so we got a nice parabola there. You guys have seen those before in Algebra 1. We're going to, again, go to the table. So again, second graph, that'll get you your table. And we'll throw down some points. Now, remember, our graph is bounded by 10. We can't go farther than 10 in either direction here. So we can go ahead and start our table at 2. Or actually, just kidding, we can go up farther here. No, we can't. Okay, so 2, 5. We've got 3, 0. 4, -3. 5, -4. 6, -3. 7, 0. 8, 5. Alright, that's enough points for us to graph. So, we can go ahead and plot these. We got 2, 5 up here, 3, 0 right here, 4, -3, 5, -4, 6, -3, and these parabolas are always going to be symmetrical, so that's why you're noticing repeated y values. And this picture really might be a little bit rough, but I'm going to try my best. Oh, geez. Okay. We're getting there. That's actually pretty decent. Oh, I ruined it. It's fine. Alright, so you'll see that it looks a lot like my graph in my calculator. So let's go ahead and note down our key points here. So x-intercepts, again, that's where I hit the x-axis, and I have 2 of them this time. One is at 3, 0, and the other, I guess I'll write that a little bit smaller, 3, 0, and the other is at 7, 0. If you look right over here, that's where y is 0. And then for y-intercepts, you can actually find, if you go up, okay, so in our calculator we can go back to the table, and remember from the last graph we said that y-intercepts are the points where x equals 0. So if you go to the x column and find where x is 0, you'll see that the y value is 21 at that point. So that tells us that our y-intercept is 0, 21. So you won't always be able to see it on your graph and your paper, but your calculator can always find it. All right, and then the minimum. The lowest point on our graph is this guy right over here. So that point is 5, -4. And maximum, so notice again how in our parabola we drew arrows, and even on our graph, you know, it doesn't stop, it just goes through the screen. And that tells us that this parabola is just going to go up and up and up forever. There is no maximum here. Okay, and so this parabola actually does have an axis of symmetry, and axis of symmetry is exactly what it sounds like. It's the line that represents the symmetry on our graph. So basically it's the line that cuts our graph into two perfect halves. And we can tell pretty easily that that's this line right over here. Okay, if you folded the parabola on this line, the two sides would overlap perfectly. And this occurs at this x value, which if we count from 0, we'd get 1, 2, 3, 4, 5. So this happens at an x value of 5. And so we're going to say that our axis of symmetry is at x equals 5. Okay, axis of symmetry is always going to be x equal to some number. So you just have to find the line that cuts your graph in half perfectly. If we go back to the other one, notice how this graph has no symmetry, so that's why there's no axis of symmetry. There's no way we could cut this in half with both sides being like perfect reflections of each other. So that is all for 112. We will continue next time.